In this video, we're going to classify triangles by sides and by angles. So we need to go over what classifications we might have. First, we're going to go over what a triangle is. You guys have seen triangles since kindergarten or pre-K even. We're going to talk about the parts of a triangle. There are vertices, which are the points. And the points in this triangle are point Q, point P, and point R. Remember, we name points by capital letters, so that would be the list of the vertices of that triangle. The sides are the segments, so we have segment PQ, segment QR, and segment PR that are the sides of that triangle. And then we have the angles. The angles of that triangle are the spaces at the vertices. So angle P, angle Q, and angle R. So those corners and the measure of those angles in them. So those are the components of a triangle. Now, those are the things that we use to be able to classify. So we have these side classifications. The first classification by the length of the sides is scalene triangles. That's a triangle with no congruent sides, where all of them will be different lengths. Isosceles triangles, which are triangles with at least 2 congruent sides. So it could be 2 or it could be more. Equilateral is a triangle with all 3 sides congruent. So we want to classify each of the triangles below by sides. So we see the dashes on the triangle here. That indicates that those segments or those sides are congruent. So we have 1, 2, 3 sets of sides that are congruent. So that is an equilateral triangle. Here I have 1, and here I have 2, and here I have 3 dashes. None of those have the same amount of dashes, so none of those sides are congruent. So if none of the sides are congruent, that is a scalene triangle. In this last one, we have 1 here, 1 dash here, and then 2 here. So I have 2 sides that are congruent in this triangle. That's at least 2, so it is isosceles. Now it's important to keep in mind that yes, this triangle is isosceles, and this triangle is scalene, and this triangle is equilateral. However, this equilateral triangle also has at least 2 congruent sides. It has 3. So we could also classify the equilateral triangle as isosceles. So that actually fits into both categories. Now we're going to look at classifying by angles. So an acute triangle, we're looking at the measures of the angles. So an acute triangle is where all 3 angles have to have a measure less than 90 degrees. So in other words, all of the angles are acute angles. In an obtuse triangle, there is one angle that is obtuse or has a measure greater than 90. In a right triangle, one of the angles has to have a measure of exactly 90 degrees. And the last one is equiangular, where all of the angles are equal. All of them are congruent. So we have these triangles down here. Notice we have 3 60-degree angles. Well, all of those angles are acute. So that would be an example of an acute triangle. But notice all of those were also equal. So this is also an equiangular triangle. So notice that this fits into both categories, and that's okay. Here we have 35 degrees, 30 degrees, and 115 degrees. One of those angles is obtuse. Therefore, this triangle is obtuse. So that's an example of an obtuse triangle. In this triangle, I have 85 degrees, 75 degrees, and 20 degrees. All of those angles are less than 90 degrees. So this is an example of an acute triangle. Lastly, we see a 90-degree angle there indicated by that box in that corner at that vertex. So this is a right triangle. Okay. Again, looking at those triangles, we would label this triangle as both equiangular and acute. This one would be obtuse because of that 115-degree angle. All of these angles are acute angles, so that triangle is acute. And this triangle has one right angle, so the triangle is a right triangle. Now notice that 60 plus 60 plus 60 is 180. 35 plus 115 is 150. 150 plus 30 is also 180. 75 plus 85 and 20, those add also to 180 degrees. The sum of the measures of angles inside a triangle is always 180 degrees. So if we look at an example here, find the measure of the third angle of a triangle. If the first angle has a measure of 66 and the second angle measures 37. So in this example, I have two of the angles and I'm searching for the third. We know all three have to add to 180 degrees. So I know 66 plus 37 plus that missing angle have to be 180. We could call that missing angle X, or we could just call it blank in this scenario. So I'm going to combine my 66 and 37 and get 103. And then subtract 103 from 180 and get 77. So the missing angle is 77 degrees. Okay, I want you guys to use that same property to find the measure of each angle in triangle RST, and then also find the value of X in example 5 and in example 6.